Okay, yesterday we did composite figures. We did found the missing side length using attributes of two-dimensional shapes and perimeter, the concept of perimeter. And today we're going to be looking at composite figures and the area of composite figures. Okay, so I'm going to share my screen, and I've got a composite figure here. Make that straight and zoom out. Okay, so here's my composite figure. And when we talk about area, we're talking about the space inside of this. And I meant to say yesterday, always remember, try to relate this to life. What could this space be? Like in school we did, do y'all remember going out in the hallway and doing with our partner, you made a little playhouse area. We did that. This is the same thing, okay? This could be like a living room and a little bathroom or something, okay? Or in your playhouse, maybe that's your kitchen and a closet or something. I don't know. It can be anything, but it is always meant to be this is a real life situation, okay? Because maybe you want to maybe that's a living room, like I said, and a bathroom, and you want to put carpet in here and tile in here, and you've got to go to Home Depot and tell them how many square feet you need, okay, of carpet and tile. So always remember, this is a real life thing. It's a model of something in real life. So there's two ways we can figure out exactly how much space is inside of this area, okay? We could count, because it's marked off in these square units, we could just count them, okay, individually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. So the area, A for area, is equal to 44 square units. And I say square units because I don't know if we're measuring in feet or centimeters. It doesn't tell me on here, okay? Sometimes it does. If it told me feet, for example, I would say square feet instead of units, okay? But when it doesn't say, we just say units, okay? Now that was kind of tedious, I think. I don't want to sit there and count every single time. So there's another way we can apply what we've already learned this year to figure out the area of this composite figure. And you got to think back to your knowledge of arrays, okay? We have an array of perfect square units here, okay? But I need to break it down. This is a composite figure, and I'm going to break this down into two single 2D figures. One way I could do it is like this, okay? There's a square right there, and then this larger rectangle, okay? That's the way I tend to see it. Or some of you might be thinking, I would have done it this way and broken it down into this long rectangle and then this rectangle here, okay? So either way, you could do that. And I'm going to go with my first way right here. I'm breaking it off right here to this square. And I know this is a 3 by 3, right? That is a 3 times 3. So I'm going to go ahead and write that over here. And what is 3 times 3? Well, it's 9, and I can see that. I could count them, but I already know my math facts. So I know 3 by 3 is equal to 9 square units. And then I've got to figure out the area of this larger rectangle. I'm not using the pink division line. I'm using this one. So I'm going to do this whole thing. This is a 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7. That is a 5 by 7. So I'm going to go over here and write that down. Well, what is 5 times 7? It's 35 square units. So if the question says, what is the area of this whole composite figure, we're going to have to add, we've got partial products here, we're going to have to add the 9 and the 35 here together, and we get 44 square units, just like we had a while ago when we counted it all out, okay? So today on your practice problems, you're going to have one of two things. You're either going to, it's just going to ask you what is the area, and it's going to have the total area to choose from in a multiple choice situation, or they're going to say, what could you use to find the area? And your answer choices would be like this. It'll be like choice A might say 3 times 3 and put parentheses around it for that part, plus 5 times 7, which is what we just did. Could you use this to find the area of this composite figure? Absolutely, you can. And then they'll have other choices like they'll put a 3 by 3 plus a 5 by 6. Well, was that right? Is that a 5 by 6? No, it's a 5 by 7. So I would not choose that one. Okay. Something else. Oh, remember how I told you we could have decomposed this a different way instead of the way I did it? I wish I wouldn't have written 35 in there. I want to show you that real quick. You're going to have to be able to see that just because the way you decomposed it, maybe they decomposed it another way. So maybe we do it this way this time, into this long rectangle and this rectangle over here. Actually, yeah, it is a rectangle. So now I've got a 3 by this whole long one, 1, 2, 3, 4, 5, 6, 7, 8, a 3 by 8. Okay, so I go over here. This is one way to do it. Here's a second way to do it. 3 times 8, got a 3 by 8, and 3 times 8 is 24 square units. I'm just going to put that. And then another way, we've got this rectangle, 1, 2, 3, 4. That's a 4 by 1, 2, 3, 4, 5. So I go over here, and 4 times 5 is 20 square units. And then I have to add those up, and it would be 44 square units. But your answer choice would look like this: a 3 by 8 plus a 4 by 5. Okay, so that could be another way. Okay, so they might decompose it a different way. So you have to be able to see, oh, you could do it this way with the long rectangle and this rectangle, or you could do it like we did the first way and see this and that one. Okay. If you have any questions, give me a call and we can work one out together, or whatever you need. Okay. So have a great day and good luck with those problems. See you tomorrow.